Hello everyone. Today I'm going to demonstrate my computer architecture project. I coded this ALU design in Verilog and I implemented it with an FPGA. So you can see the ALU has two 4-bit inputs and two 8-bit outputs. One of the outputs is the output for the current operation. The other one is the output for the previous operation. So now comes the FPGA. I used the Nexus 4 board with a Xilinx FPGA. Used Vivado to program this board and Verilog to implement the design. Let me turn it on. Program the FPGA, program the ROM so that the code can run on boot. So it takes a while to turn on, but it should start up. Okay. So the clock was slowed down from 100 megahertz all the way to 1 hertz. So this is the LED is turning on every second. So now I will be demonstrating some examples I put up. This ALU the FPGA uses the first 4 switches, sliding switches for the B input. These other 4 switches for the A input. The third set of switches for the address to save to memory. I also implemented a 16 address memory. And then the last 4 are for the opcode. And well, here goes the first example. So let's start with opcode 0000, which is addition. This one adds A and B, so let's put a 0, 1, 1, 1 in B, which is a 7, and a 6 in A. We're going to store this in address 15. And where is wait 0, 1, 1, 1, 0, 1, 1, 0, address 15 there. And well, opcode 0, just gonna do addition. So now you click the calculate. Alright, we get our output, which is 13. You can see here. Now we're gonna go on. Okay, in order to save I have to click this top button, so I save it to address 15. Alright, so now the second example, subtraction. So opcode 0001, input for B is gonna be a 4. Input for A is going to be 1, 0, 1, 1. Alright, we're gonna save this into address 14 and opcode 1. Alright, so now we calculate. You can see current output was moved to the previous output. You see 1101 moved to 1101 over here to this register. Well, this register has a current operation. You can see A minus B give you 7. Right? This is what we see here. Okay, so now comes the fun part where you can reuse the previous operation or to do a current operation. So let's say you want to do A plus the previous. So we're going to use A 1, 2, 3, 15 minus the previous, which is going to be a 1101, 7. I'm going to save this into address 1101. Right? And opcode 0010. Right, so press calculate. This is the output we get. Since it's an 8-bit output register, you can get a calculation up to 8 bits. You can see It is correct. Okay, going on to the next example. We'll save this. A minus the previous, so now we change A to a 1101 and B, so don't care. So you don't care about B, you can ignore B, right? So 1100. I'm gonna save this into 1100, right? Opcode 0011. This is gonna be A minus the previous. We should see this output. And that is what we see. 5. Right, so now going on to next operations. A times B, I'm going to put 15 in A, in B, and A 4 in A. Now we're going to save this to address 1011. Now opcode is 0100. So now let's calculate this. Right. So according to this, we are correct. The ALU is working as it should. So now next in line, A divided by B. Right, 0010 for B. So you can see A divided by B, 0010. Then 1110. I'm going to save this into address 61010. Right, opcode for this 0101. Right, see what happens. Divide it, which is correct. So got here 14 divided by 2 should give us an output of 7, and this is what we see. So now save the current operation. Right, so now comes another fun part. So this is a dynamic ALU. This means that either of the inputs can be used as a secondary output. So in the case of the shifting, I use the format for shifting. Opcode is going to be 0110, and depending on the input for B, for the most significant bit, you shift right with a 0, you shift left with a high. So, and then the last 3 bits of B is a quantity to shift. So let's say the first example, 0010, this means you shift right by 2 bits. Second, you shift left by 3 bits. So you would shift A accordingly. Now, let's try this out. So you put a 1000 for A and a 0010 for B. This means you're going to shift A to the right by 2 bits. Opcode is going to be 0110. 0110. We're going to save this into 1001. Oh, wrong one. Opcode 0110. I'm going to save it into 1001. So now let's try this out. And yes, A was shifted right by 2 bits. This is the output you see. So you have your 8. Well, the most significant bit, the 4th position, move it by 2, should be now in the 2nd position. This is what we see as the output. Right? So now let's save that.